Okay, welcome everybody. I'm excited to talk today about the key aspects of web performance, and that's the core web vitals, and specifically about INP, or interaction to next page. I think we all at that moment when you're visiting a website and it feels really unresponsive. INP is a new core web vital metric, and that measures how quickly a site responds after a user interacts with it. Like clicking a button or typing. It's critical for making the website feel fast and smooth. And today we are going to explore what INP actually is, how you can measure it, and eventually how you can fix those issues. First, a little bit about myself. My name is Sander van Surksum. I'm a father of 4 daughters. I have a lovely wife and a very house full of energy with all those girls in my house. I work in the web since 2003. I started as a front-end developer, but always had a strong focus on user experience, and especially on making the websites feel enjoyable. I joined a company that was specialized in conversion optimization, and that's when I saw the correlation between web performance and also conversion. And that's where we find out that if a website performs well, people tend to stay longer and convert better. So that's, I think, was the moment when I got really passionate about website performance, and I specialized in website performance. Outside of my work, I'm also a part-time muralist. I create murals. I don't have much time lately, but I hope to pick it up anytime soon. I also share lots of performance tips on LinkedIn. So if anyone wants to know the latest insights on performance, you can follow me on LinkedIn. I try to post a tip each day. Even today, I posted something about the scheduler yield API that I'm going to show. So if you want to get some insights, you can follow me on LinkedIn. A little bit about our business. I have a company that's called Iron Out, and we help businesses worldwide to increase the customer engagement and sales by making their website faster. And why are we doing that? Basically because speed matters. So a fast website isn't just about performance. It keeps users happy, engaged, and eventually they are coming back. So when a website responds quickly and instantly, customers are likely to stay longer and convert better. That's mainly the reason why it's really important to have a good performing website. We work for a variety of clients. These are some of the brands we work for. Most of them are in e-commerce, telecom, and publishers. And the main reason for that is because performance is really important in these sectors. Introduction to INP. So that's the talk for today. INP is a key metric, and that helps us understand how responsive a website feels after a user interacts with it. So, as we know, speed is not about how fast a page loads, but also how quickly it responds when you start clicking, typing, or scrolling the page. And that's especially important because websites today are getting more interactive. So we use much more JavaScript to make those pages more interactive. And users expect those interactions to happen smoothly and instantly. And INP is a metric that measures exactly that. So how quickly your site reacts to a user input and shows a visual update. So before we dive into INP, I want to get a quick sense of the room. So please raise your hands if you have heard of INP before today, or Interaction to Next Page. Cool. So, yeah, a lot of hands. Nice. And who is now currently measuring the performance on their website? Does anyone do real user monitoring on the website? So, cool. So some of you are already familiar with loading metrics like largest content for paint, first content for paint. Cool. Yeah, those metrics measure the loading, and the metric that we're going to talk about today measures a little bit different things. It measures the interaction. Last question, has anyone heard about the new Scheduler Yield API? Anyone? Cool. Now, then you get some new information today, because we're going to talk about how you can use that API to free up the browser so you can give some space for more important stuff. So interaction to next paint. Like I said, it measures how long it takes for the browser to visually respond to a user interaction. So in other words, it tracks the time between when a user clicks, taps or types something, and when they actually see a visual response on the screen. So think about when you click a button or submit a form or you tap a link on your phone. INP measures the delay between that moment of interaction and when the page visually changes to show your action was registered. So that's basically what INP is. And that's really important because the users expect a website to feel responsive and not only load quickly, but actually respond quickly when they start interacting with it. So even if a page loads fast, if it feels slow when the users try to do something, then the overall experience is still a slow experience, and that creates frustration. So INP helps us to quantify that experience. I think some of you maybe thought, oh, we already had a metric for measuring responsiveness. That was first input delay. What about first input delay? INP is a new core web vital introduced by Google and has replaced first input delay since March. And why? Because INP is, I think, a better metric, because first input delay only tracks the first inputs or first interaction that users had on the website, and INP measures all interactions on the page. Why is that important, and why is INP a better metric? This is an interesting fact from Google, and what they basically say is over 90% of the time users spend on the page is after it has already loaded. So that's huge. So often we focus much on how fast the page loads, but most of the users' time is spent after the page is loaded. And that's the time that they're going to start interact with the page. So they're going to click, scroll, navigate. So that's the most time that they spend. And that's why INP is really important. So it doesn't just measure how fast the page loads. It tracks how fast it responds to every interaction. So by improving INP, you're not making sure that the users have a smooth experience during the loading, but you basically say that you optimize the stuff that is after the loading, so for the whole life cycle of the page. Like I said, INP is part of the core Web Vital metrics. The core Web Vital metrics are a set of metrics created by Google, and they measure the page experience. They consist of three topics. It's loading speed, responsiveness, and visual stability. And we are going to focus on the responsiveness part today, and that's where INP, interaction to next page, stays. Google also created some thresholds for the INP, and these are the thresholds. So if you have a good value for INP, so below 200 milliseconds, then interactions feel almost instantly. so people won't feel a delay, and interactions feel instantly. If you are between 200 and 500 milliseconds, they say you need to optimize it, so you are in the need improvement. And if it is above 500 milliseconds, the delays are really noticeable, and people are getting annoyed. So below 200 is good. Now, what exactly is an interaction? What happens during an interaction? This is a visual representation of the main thread. And when you click, tap, or type, the browser doesn't instantly update the screen. There are actually multiple steps involved. First, the browser needs to register the input, and then it processes the input, running all the event handlers or functions, and finally it visually updates the screen. And this entire process, registering the input, processing it, and then updating the UI, and that makes up what we call an interaction. So let's dive into these 3 steps. So we start with the user input, and that's the moment when the user interacts with the page, such as clicking or tapping on the screen. And once the input is received, the browser begins to process it, and but there can also be a delay before the processing starts. There can even be a delay to receive the signal from the physical keyboard to the browser. So this input delay, which happens when the main thread is busy with other tasks, and then the browser can't respond immediately. Then we have the processing time. So once the input is recognized, the browser begins handling the event. And this could involve running functions or handling mouse events or keyboard events, for example. And the time it takes for the browser to execute all of this is the processing time. So if there's a heavy task running like JavaScript, this can all increase those of the processing time. And then after that we have the presentation delay. So after the event has been processed, the browser needs to render the visual update. And this involves creating the new frame and painting it and displaying it eventually on the screen. So the time it takes to render the next frame is what we call the presentation delay. So all these steps together, input delay, processing time, and presentation delay, form the complete interaction to next paint. And basically this is really critical measure on how quickly the website responds to any user interaction. What interactions are measured? Are all interaction measured? Not exactly. We start with clicking the mouse. So every time you click a mouse or a link, or you click a mouse button, link, INP measures how fast the page responds. The next one is tapping on a device with a touchscreen, like on your phone or on your tablet. INP tracks how quickly the page reacts to that. And finally, pressing a key on a keyboard. So when you fill in the form or press a key on a keyboard, that's also part of what INP looks at. What about hovering or scrolling? That does not factor into INP. Only when scrolling the keyboard, when it's tied to a key press, then it's also part of an interaction that is measured. Okay, so how can we experience those delays? I created a little demo app. It's basically a product detail page. If you want to try it out yourself, you can scan this QR code to go to the URL that's at the bottom. Basically what I've done over here is created a product detail page with a typical color switch. And with a lot of clients we have experienced problems that when users were trying to change the color for the products, that there was a delay. And that's what I tried to simulate over here. Hopefully those delays are already visible. Maybe also good to mention, I have opened the new performance tab in Chrome DevTools here. They launched it, I think, 1 or 2 weeks ago, but it will give you really nice insights for debugging core web vitals. And what you can see on the left is the demo page, product detail, and on the right we have the insights on the performance panel. And here at the bottom you can see interaction to next pane. So it hasn't registered anything yet, but once I start clicking on stuff, it will hopefully register stuff. Yeah. And here you could see that it has registered my interaction. It's a pointer on a certain button, and it also measured the delay. Now I had a delay of 440 milliseconds, but this one is even higher. And this one is really noticeable. It's a delay of 3 seconds. And yeah, that's really bad for the user experience. I forgot to show this. This is even better, then you can even see it. What I'm going to do now is trace the interaction. I create a performance trace. Then if I stop it, you can actually see the long task that it created. So what we here see, it registered the click, but then it's still red, 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 and now it goes to orange. So there's a huge delay between the interaction and updating the UI. And basically that's caused because of the long task. So the browser is busy with processing that task and doesn't have any time or room to update the UI. And that's basically causing the delay. So why does it matter, INP? Why is it such an important metric? I already showed you guys that 90% of the time that the user spent on the page is after it has loaded. But I think it's good to understand what type of users are using your website. If we look at, this is a snapshot from this week. This is the Amazon bestsellers, mobile phones, current ones. And as you could see, we have a lot of budget Android phones as one of the top sellers. Or the first 3 are budget phones. So this is really important to keep in mind, that a lot of the users that are on the websites that we create are on these budget phones. So they experience much more delays than I think most of us have high-end phones. So they experience much more delays on those websites because the processor isn't as fast as those high, more performing phones. This is a quote from Ilya Grigorik. He created, I think it's from a book, High Performance Websites. But I think this tells the story. So it's really important to remember that measured performance and perceived performance do not always align. I think we as engineers, we often measure the time in seconds, but all the users that are using our website, those people measure the time more differently. They measure it in pain, boredom, or more frustration when something is slow. So those slow responses doesn't just waste our time, it actually causes frustration, and that leads to poor user experience. So on the other hand, the faster experiences, those can reduce that irritation and make everything feel much smoother. So when we prioritize performance, we directly improve the user specifications. And speed is not just a technical achievement, it's more an emotional one. This is a Geekbench screenshot. Alex Wasso from Microsoft, each year he creates an article about the performance in equity gap. And basically what you can see over here is that the gap between those high-end phones and budget phones is getting larger over time. So the phones that I showed in the screenshot from Amazon, those are all phones, I think, in line with the orange line. So those are the more budget phones. So the gap between those high-end phones and those budget phones is getting bigger and bigger. So it's really important that we create those experience for all the users and not only for the people that have iPhones. Another thing why it is important to improve INP, and especially on mobile, is that we see that INP on mobile has a stronger correlation with business metrics than INP on desktop. And what kind of business metrics? This is a screenshot from SpeedCurve, and SpeedCurve is a tool where you can measure the performance. You can do synthetic tests, but also real user monitoring. And the good thing about their real user monitoring is that you can also correlate it with some business metrics. What you can see over here is on the vertical X you see the amount of sessions, and on the horizontal X you see the INP value, and the blue line is the conversion rate. And basically what you can see over here is that the sweet spot is around 100 milliseconds. So there is a correlation with conversion. These are also some real use cases. This is from Redbus. This is a use case published on Google on WebDev. And they improved INP by 72%. And by doing so, they saw a 7% increase in sales. So it's a really nice business outcome. This is a publisher where performance is also really important, and especially also the responsiveness. And they improved INP 4 times. And they saw an increase in page views. So people tend to stay longer on the page. And they also saw a reduction in bounce rates. So some really nice results. And this is one of our own case studies. We work for a company called Phrases Group. And we improved 3 of their main websites where we improved INP. And we saw also a really nice uplift in conversion. So there is really a strong correlation between the user experience and conversion. So debugging those slow interactions. So how can you debug those slow interactions? I have now summed up 3 ways to do that. One thing that you can do is install real user monitoring. And basically, real user monitoring measures the performance from all the users on the platform. I've listed some of the ones that we use. So one from the Netherlands is Rumvision. It's a really good one. We use Debug Bear, Calibrate, Trio, Honeycomb. And by the end of the day, actually, Bram Kaashoek is going to do a talk about Honeycomb, on how you can use Honeycomb to do front-end observability, and especially how you can measure core web vitals and INP with Honeycomb. Another way to find those INP issues is to use the page experience report in Google Search Console. I don't know if anyone is familiar with that, but they have a really nice report based on the Crux data set from Google. And the Crux dataset is basically a dataset gathered by all the Chromium users. And you can query that dataset and you can see performance insights on your website if you have enough visitors. And another way is to use the Chrome DevTools, what I showed you before. You can open the Chrome DevTools, go to Performance Panel, and record user interactions. And the nice thing from the new Chrome Performance Panel now is that you can correlate your local values with the ones from the Crux data set. So this is the new performance panel. Like I said, as you could see, for this page we have Crux data. So you see a difference between local and what Google has from real users. So this gives you a really nice overview, and yeah, you can basically debug all the interactions on your page and see what the values are. And it even gives you the attribution data, so what element is causing that delay. Identifying culprits. In the demo I did before, I did a performance trace. So when you found out that you have a slow interaction, you can create a performance trace, and that will give you something like this. So this is the main thread, what you can see over here, and a really long task. And basically it gives you all the functions that are run when you click on in this thing. It was a button, when you click a button. And what you can see over here is that there's a lot of things going on. So when we click on the button, there is something pushed to GTM. We have Facebook in there, we have TikTok in there. All things that are not really important for the user, but they have to be done because something needs to be registered. But this is not really critical for the user or for the interaction at that moment. So yeah, these long tasks, these prevent the browser from processing the input and updating the UI quickly. This is another one, and this one is not JavaScript related, but we see it quite often. This is a long task, and that's basically caused by recalculating style. And this is basically because we see a lot of animations being done on properties that force reflows. And basically what people often do is try to animate top, left or right properties in CSS. And that's quite heavy for the browser. So only try to animate the transform and the opacity. And don't try to animate everything else, because those animations can cause really long tasks. This is a typical function that we see often. So we have a function that saves stuff when you send a form. It does a validation for the form. It shows a spinner. It saves it to the database. Then updates the UI and sends it to analytics. So there's a lot of stuff going on, but not everything within this function is critical for the user. And that's where yield patterns come in handy. And basically, yielding is a kind of pausing the task so that other things can happen. So like responding to a button click. So once things are done, JavaScript picks up where it has left off. So this makes it sure that everything stays smooth and responsive. And we can do this with set timeout or with request animation frame. But we can also do this with other APIs. Yeah, like I said, we can do this with a set timeout. So what we did over here is urgent feedback to the user. We give it more priority. And then we defer the non-critical work to a next task. And basically what you do over here is you free up the main thread so that the main thread can perform some other tasks that are more critical to the UI. We can also use the new scheduler yield API. There's only one person in the room that is familiar with this, so yeah, please try it out. Google released it in Chromium 129, I think 2 weeks ago. And basically this is a new API to improve how website handles those long tasks. And it allows developers to break up those tasks into smaller pieces. So the browser has a change to pause and take care of other more important things, so like responding to user clicks and updating the UI. This helps keeps the website responsive, so especially during some heavy tasks. Why it is useful? It's useful because it helps avoid the problem of the long task blocking the main thread. So normally when a task takes too long, it can make the website feel slow or unresponsive. And with scheduler yield, the task pauses briefly and allowing the browser to handle the important tasks like user interactions and rendering updates. So this makes the website feel much more faster and smoother. And it also reduces the visual stutter or the jank in animations. How does that look like? So what we can see over here is also a representation of the main thread. So we have a really long task where we receive the input, and then after the long tasks, the event handler runs, and yeah, that's ready for the interactions. And after we yield to the main thread, we have much smaller tasks. So we break up the long task so that it has more time for other important stuff that's in the queue. And this is a visual representation for without yielding, using set timeouts and using scheduler yield. And basically what you can see over here is why we prefer scheduler yield over set timeout. And that's basically because scheduler yield, when you yield to the main thread, it delays the non-critical stuff, but it places them after the next queued tasks. So it still can be that other stuff like third-party scripts are in the queued task and still delaying the continuation. So that's why we prefer now the scheduler yield, the new API. And scheduler yield does the continuation right after the render. And then the rest of the tasks are coming. So you have much more control now with this API. So scheduler yield is really useful in real-world scenarios, like breaking up those heavy data processing or rendering lots of items on the page. Or handling long running loops. And it also helps maintain smooth animations by giving the browser time to respond to those interactions and visual updates in between those tasks. This is an example where we're loading products into a page in batches of 20. And after every 20 products, we yield back to the main thread. So that gives the browser the chance to process other tasks and ensuring that the page stays responsive as we add some new items. So how can we use that in the demo that we had previously? So this one, what we can see over here is now we have one long task, and what I did over here is I blocked the main thread for a delay. Actually, I block it 8 times for a certain amount. And the only thing, basically, what we need to do over here is use the new API. As you can see, it isn't recognized yet, but hopefully it works. Quickly see. And now it should feel instantly when we change those buttons. And how does that look like when we run a performance trace for this page? So here we now can see that this is the pointer, so this is the interaction that we had, and it has broke up those long tasks into smaller pieces. And yeah, this way the UI update is feeling instantly for the users. Oh. So, what are the benefits for performance and the user experience by using yielding, or in this example, scheduling tasks or schedule yield? It is for keeping your website responsive by allowing the browser to handle those interactions in between tasks. And it also helps avoid UI freezing and ensures some smoother animations. So by optimizing those responsiveness, it improves your INP scores eventually, and that creates a better user experience. And it's basically a really good way to break up those long tasks. So when do we not have to use the scheduler yield? It's really great for breaking up long tasks, but it's not always the right tool. So if the tasks are already small, yielding to the main thread can add some unnecessary pauses. So it also doesn't help with the tasks that need to run synchronously. So overusing is also not good, because that can slow things down if tasks are breaking up too much. So use it wisely. Currently, the support is only in Chromium browsers, so the support isn't as wide. Global, it's 44%, but you can already use it, because as we saw in the previous, and especially in the screenshot from Amazon, the devices that have issues with long tasks are mostly the devices on the budget devices. Most of the Chrome users are using Chromium browsers, so you can definitely already use it for that amount of users on your website. You can also polyfill it. So basically what you say is, if scheduler yields is supported, use scheduler yields. Otherwise, use set timeout or request animation frame. But in this example, we use the set timeout. So some best practices. To improve INP, we created some key points to keep it in mind. First, you need to prioritize the UI work and focus on elements that users see right away, and defer all the invisible tasks like analytics, background scripts. You can all defer them until later. Avoid creating large complex layouts, and minimize layout thrashing, which is when the browser has to re-render too frequently. That can also cause some INP issues. For one of our clients, they had a really large INP issue on a product listing page, but they were showing 180 products over there. And only by reducing the amount of products on the product listing page to around 90, I think we reduced INP by almost 200 milliseconds. So a really large DOM can also be a cause of INP issues. Use native APIs where possible. We still see that a lot of developers use packages for almost everything, but there are some native APIs available that can replace those packages, like the dialog, the popover, the details for FAQs. You can now even animate the details elements. And there's also the new view transition APIs, which you can use to create really nice animations between page navigations. Make sure to yield to the main thread during expensive functions to prevent blocking important user interactions. And lastly, finish execution faster. So improve runtime efficiency. So minimize your JavaScript footprint, abort unnecessary tasks, and that will keep your website responsive. Finally, let me leave you with this. Make a journey enjoyable enough, and nobody is that bothered about how long it lasts. And I think this is the heart of the user experience. It's not just about speed. It's about creating a journey that's smooth, engaging, and memorable. When users enjoy the experience, so even the small delays don't matter as much. So, as we improve the site performance, let's keep users on making the journey worthwhile. And because when users feel good about the experience, they probably stay longer on your website. So that's it, basically. So good luck, everybody, with improving website.